Now, next topic is acceleration due to gravity. Now, the acceleration produced in the motion of a body under the effect of a gravity, as you can see in this image, is known as acceleration due to gravity, and it is denoted by g. The value for g is known to all, that is 9.8 meter per second square. So we know that when force acts on a body, it produces acceleration. Therefore, a body under the effect of gravitational pull must accelerate. So let us consider a body of mass m here, that is lying on the surface of the earth. As you can see, we have a body m and it is on the surface of earth. Then gravitational force on the body is given by F equal gm m r square. Now the bigger m is the mass of earth and the small m is the mass of object. Now as you can see, the distance between earth and the object is nothing but equal to radius of the earth. So r will be, the small r will be radius of the earth, or you can take it as big R as taken in figure. So it will be r square. R is the radius of the earth. Now, as you know that for the force is nothing but mass into acceleration. Now, as we are considering it acceleration due to gravity, that means it is a free fall. So, in the condition of free fall, we replace A with G. That means my second equation is m cross G, and my first equation is gmm dot r over r square. Now, we need to compare these two equations, 1 and 2. So when we compare, we cancel out force on from the left hand side. So it will be mg equal gmm r square. Now you can cancel out small m with m. So you are left with g equal universal gravitational constant, that is big G, over m r square. Now as you know that the body is a sphere. So sphere is replaced by 4 over 3 pi r cube rho. That is, mass is equal to volume into density. So your formula will be G 4 by 3 pi rho G r. So this is a gravitational constant under gravity under, this is acceleration due to gravity. So that's the end for this part.